In this example, we're being asked to calculate the integral for a piecewise function. So first of all, let me go ahead and write up what our piecewise function is. We're given that f of x is equal to 1 if x is less than 1. It's equal to x for x greater than or equal to 1, less than or equal to 2. And it's equal to 4 minus x for x greater than 2, but less than or equal to 5. Given this piecewise function, we're being asked to calculate the integral as x goes from -4 to 5 of f of x dx. Now, if you look at this, it'd be very difficult to just calculate the integral directly because we don't have a single individual function. What we have is a piecewise function, meaning there's different functions depending on what my x values are. So, to do this, I'm actually going to be interpreting the integrals as net signed area. That is, I'm going to graph this, and hopefully I'll be able to just use plain old geometry to figure out what my areas are. And then I'll just keep track of whether I should be adding them or subtracting them, depending on whether they're above or below the x-axis. So, let me start by graphing my piecewise function. So first things first, our integral is starting at -4, so I at least want to tick mark my graph that far down. And it's ending at 5, so I want to go up that high as well. Okay, put a couple tick marks on the y-axis as well. And let's see what we got. So for x less than 1, we're just graphing the function y equals 1. So here over at -4 is as far down as we go, and then it goes up to 1 and stops. So I'm starting off with a hollow circle because I'm noticing this says strictly less than. So I think this is probably going to overlap as we go, but if it didn't, if I started my function elsewhere, I need to pay attention to whether these are hollow or closed-in circles. But now, we're going for x in between 1 and 2, and sure enough, we've got x greater than or equal to 1. And less than or equal to 2, we're graphing the function x. So at 1, we get 1, so that gets filled in. At 2, we get 2, so that gets filled in. Again, less than or equal to 2. Now I look at my other function. For x strictly greater than 2 and less than or equal to 5, we're graphing the function 4 minus x. So when x is 2, 4 minus 2 is 2. So even though it's a hollow circle, it goes over right there. And then for 5, 4 minus 5 is -1. So that would be right here. And we can see that's linear. So I'm just going to connect these now. And I'm going to make a note that at 4, I'd have 0. So it's going to go like that. My best attempt at a straight line. Okay, so now I'm just going to drop down to my x-axis. Notice that this one was below the x-axis. And let's go ahead and shade in these areas. I want to find this area. I want to find this area. And I want to find this area right here. Notice that whatever this area is, I'm going to be subtracting it because it's below the x-axis. So now that I've graphed this, all of my shapes are pretty straightforward, and I can just use geometry to do this like I was hoping. First of all, this triangle here, I'm actually going to cut it into 2 to make my life easier as far as figuring that out. Okay, now let's see. The easiest way it's going to be to do this is actually, let's group that area together as well. And let's look at what we've got here. I've got the area of this rectangle. I've got the area of this little triangle right here, the area of this bigger triangle, and the area of that triangle right there. So, how am I going to figure out the area of this rectangle? Well, the area of a rectangle is just length times width. So the length is 1, 2, 3, 4, 5, 6 units long, and then a height of 1. So we've got 6 times 1 for the area of that rectangle. What about the area of this little triangle? Well, its base is 1, its height is also 1 from 1 to 2, and the formula for the area of a triangle in general is half base times height. So a half, 1 times 1. What about the area of this triangle? Well, this one has a base of 1, 2, and a height of 1, 2. So that's going to be 1 half 2 times 2. Finally, what about the area of this triangle right here? Again, same formula. It's got a base of 1 unit long and a height of 1. And so this area right here is going to be 1 half 1 times 1. So if I go ahead and calculate these numbers, that's just a half. A half times 2 is 1, and then times 2 is 2. This is just a half. And this, of course, 6 times 1 is just 6. So now I have all my areas, so I can just go ahead and set up what my result's going to be. It's going to be 6, because this is positive area, plus 1 half, because this area, again, is positive. It's above the x-axis, plus 2. But now, the area of this right here, since this was below the x-axis, I'm going to have to say minus 1 half. Notice the 1 halves drop out, and I get 6 plus 2, which is 8. And so the total area underneath this integral, the total net signed area, comes out to be 8. So if you're given a function that you're trying to evaluate the integral of, and when you graph it, everything can be cut up into nice geometric little shapes, then you can always just calculate the integral that way when it might be really strange or difficult to evaluate an integral directly. And that is this example.